4 and 7, and 2 and 3. The other contains 2 ignition coils for cylinder pairs 5 and 10 and 8 and 9. The automatic shutdown, or ASD relay, provides power to each coil. The PCM, or the ignition module, provides the ground to each coil, which causes spark plugs on 2 cylinders to fire. One cylinder fires on the compression stroke, the other fires on the exhaust stroke. By the way, the spark plugs used on the V10 are RC9 MC4. The gap is 45 thousandths. Spark plug wires are 8 millimeter. Wires for the odd cylinders are routed through a plastic tray at the front of the engine. The firing order of the V10 is 110, 94, 36, 58, 72. In order for the PCM to time the coils and injectors, it must first establish a reference point. This requires inputs from the crankshaft position sensor and the camshaft position sensor. The crankshaft position sensor provides the PCM with crankshaft angle and speed. How is this done? A crankshaft pulse ring contains 10 notches. Each notch represents a signal for a specific piston. As the crankshaft pulse ring rotates past the crankshaft position sensor, these signals are sent to the PCM. The PCM converts crankshaft speed into engine RPM and crankshaft angle into piston position. The crankshaft position sensor is located on the right side of the block. The camshaft position sensor receives signals from the notches on the camshaft timing gear. The timing gear has 2 single notches 180 degrees apart and 2 notches next to each other. The notches indicate which piston is approaching top dead center. The camshaft position sensor is located on the left side of the timing chain cover. Based on the inputs from the crankshaft and camshaft position sensors, the PCM energizes the appropriate coils and injectors. That's a look at the V10 ignition system. Before we move on to the V10 fuel system, I've got a question for you. Which cylinder pairs are controlled by the ignition module? A, 1 and 6 and 8 and 9, B, 5 and 10 and 4 and 7, or C, 5 and 10 and 2 and 3? The answer is B. Cylinder pairs 5 and 10 and 4 and 7 are controlled by the ignition module. The 8-liter V10 is equipped with a paired multi-point returnless fuel injection system. The system is returnless because fuel is regulated at the fuel pump instead of at the fuel rail. Therefore, no fuel return line to the fuel tank is necessary. The plastic fuel tank has a capacity of 35 gallons. The fuel pump sending unit module is installed inside the fuel tank. A pressure regulator located on top of the fuel pump module maintains fuel pressure of 40.2 psi at all times. The fuel pressure regulator supplies only the fuel needed by the engine. There are 2 tubes on the fuel pump on standard duty vehicles. The 3/8-inch tube supplies the fuel rail with fuel. The 1/4-inch tube is the fuel vapor line. On heavy-duty vehicles, there is a 5/16 of an inch tap for auxiliary fuel supply for cab chassis vehicles. The one-piece fuel rail is mounted to the lower intake manifold. A quick connect coupler is used to attach the fuel supply tube to the fuel rail. Before reconnecting the fuel line, the male tube on the fuel rail should be lubricated with engine oil. 10 top-feed high-impedance injectors are mounted on the lower intake manifold. All injectors are pointed toward the right side of the engine. On the left bank, this is necessary for air cleaner clearance. On the right bank, it is for EGR clearance. Remember, the fuel injection system is under pressure. Always use the fuel system release procedure before servicing the fuel system. There are a number of inputs and outputs for the fuel and ignition system similar to those on the 5.9-liter V8. A chart is provided in the reference book. We've provided you with information about mechanical, ignition, and fuel systems on the 8-liter V10. Now let's answer a review question about the fuel system before moving on to the Dodge Ram pickup's Cummins diesel. In order for the fuel system to be returnless, what component had to be moved to the fuel tank? A, the pressure regulator, B, the fuel pump, or C, the fuel rail? The answer is A. The pressure regulator had to be located at the fuel tank so that only the necessary amount of fuel would be sent to the fuel rail. For 1994, there have been a number of changes to the Cummins turbo diesel. The engine with the automatic transmission is now rated at 160 horsepower at 2,500 RPM, with a peak torque rating of 400 pounds-feet at 1,600 RPM. Manual transmission engines are rated 175 horsepower at 2,500 RPM, with a peak torque rating of 420 pounds-feet at 1,600 RPM. Let's start by taking a quick look at the components that have changed based on their location on the engine. On the fuel pump side, the fuel water separator has been relocated using a remote mount filter head. A new plunger-style fuel transfer pump is also used. The new pre-filter and the fuel heater are located near the pan rail. The fuel pump change also required the use of new fuel supply and return lines. The throttle bracket has changed, and the throttle position sensor has been moved to make room for the Bosch P7100 inline fuel pump. A new style air inlet and fuel shutoff solenoid are also used. Finally, the coolant temperature switch has been replaced by a transmission fluid temperature sensor mounted on the transmission. On the front side of the engine, there's a new fuel pump drive gear that has no timing marks, and it's not keyed to the fuel pump shaft like it was before. A new gear housing and front cover are used to provide support for the added weight of the fuel pump. A new external coolant vent line has been added. The most noticeable change on the exhaust side of the engine is the waste-gated turbocharger for additional boost at low engine speeds. The boost pressure sensing line is connected to the wastegate actuator to control the wastegate based on intake manifold pressure. A lower capacity oil pan is used, and the motor mounts on both sides of the engine have been relocated. Changes to accommodate the automatic transmission include a new shot-peened flex plate and the use of a thicker transmission adapter for the new torque converter clutch. Since there are so many changes in the fuel system, let's take a look at fuel flow on the 94 diesel. Flow has changed due to the new Bosch P7100 inline fuel injection pump, which takes the place of the distributor-type fuel pump used in previous model years. Fuel flow begins at the supply tank, where it travels to the fuel heater, which also contains a fuel temperature sensor to monitor temperature. The heater is now located atop a pre-filter. The new pre-filter contains a number 25 mesh screen that removes impurities in the fuel. A high-volume plunger-type fuel transfer pump with a minimum pressure of 18 psi draws fuel from the tank and through the heater and pre-filter. The pump is driven by a special lobe on the camshaft. Fuel then flows to the remote mount filter head, where it flows into a new fuel water separator filter. The supply pressure fuel line from the fuel filter head provides fuel to the inlet of the inline fuel injection pump. The new Bosch P7100 inline fuel pump is capable of delivering fuel injection system pressures of 17,000 psi, compared to